Now we have Michael McCann, Managing Director of Lava Blue, a leader in high-value mineral processing for the energy transition. Michael has been involved in energy and resources for over 3 decades. He's a serial entrepreneur, having founded the Mt Rosey Mining Company in 2009 to acquire and develop the Lava Plains mineral province. Over to you, Michael.
Thanks, Jamie. It's a great pleasure to be here today. And thank you for everyone who's attending online. I just want to start with a warning. Every picture that you see today is actually us. There's no stock pictures in this presentation. So at the moment you're looking at some of our research team at QUT, and you might wonder what a company like us is doing with so many scientists involved. It's fairly straightforward. First, however, I have to have the disclaimer. Again, that picture there, that's Lava Plains processing of some of the raw materials that led us to work with QUT some years ago, producing high purity alumina. So what problem are we solving? There is no energy transition without a whole lot more mineral processing. Australia has to invest in the middle, the midstream processing. This is the value add to participate in supply of critical minerals for the energy transition. Critical minerals for batteries and magnets and semiconductors aren't your average industrial metals. They require high degrees of control, and there's no shortcuts to achieve the degree of process control and materials handling that you need to be able to bring to bear on battery grade materials. Lava Blue has entered into this market with high purity alumina. We're bullish about high purity alumina. Everybody says, what's high purity alumina? Well, it's every light emitting diode in the world. So it's actually in the room with you right now. Everybody has light emitting diodes, LED lights. You can't make an electric car without LEDs. You can't make a phone without LEDs. These days, micro LEDs are the substance with which the components for the high resolution screens and TVs. You see them in billboards, LEDs. But LEDs is just one. That's the base case consumer for high purity alumina. It's now going through an adoption curve where it's being used in a whole range of other applications. And one of the drivers of growth is its use in as a battery material in ceramic coated separators and various other applications, coating anode and cathode. So we're very bullish about high purity alumina, or HPA, and we've come to this market to perfecting a method for the production of high purity alumina, and we're running a licensing model. So Lava Blue is providing support to other companies who want to produce HPA into this booming global market. It leverages other people's projects. It uses, in a sense, other people's capital. We provide the science, the engineering, and the methods for maintaining the quality required for this high purity material. And it gives us a number of opportunities to enter into the market. This is actually an old chart. I just want to show you something, because this is one of those rare moments where you look back and say they were right. This is a projection of high purity alumina markets made in 2018, suggesting that by 2022 we'd have about 70,000 tonnes globally. This is a drop in the bucket in the mining game, where 70,000 tonnes wouldn't fill a bulk loader. But the global market for HPA is growing at around 20% compound annual growth per annum. By 2030, it's going to be at least 300,000 tonnes, and I think there's more upside. It's very high value material. So this is where Lava Blue and Australia needs to play in the battery materials market. High value, high purity, high specification, high performance materials. And so I thought I'd put that up there because we believe that the relatively rapid adoption of energy efficiency technologies, energy efficiency and the technologies to deliver that, and batteries is going to drive this even faster than was predicted. Australia supplies basically no high purity alumina at the moment, but is in the box seat because of the wave of new capital being invested in critical minerals projects to be a significant supplier of HPA by the end of this decade. And how are we doing it? Well, we're actually doing it. So we've built, after several years working in the laboratory, we've built a mineral processing demonstration plant in Redlands in the southeast of Brisbane. We've spent about $8 million so far on this facility, and it does that essential step of scaling up the technology beyond the laboratory, and we de-risk the money by de-risking the technology. So our whole approach here is to invest in that midstream processing, demonstrating opportunities for making various types of HPA at a scale that the engineers can then use to much more safely scale up to commercial production at thousands of tonnes per annum. This is the picture you're looking at is the Centre for Predictive Research into Specialty Materials. That's because we use machine reasoning, machine logic in the control of our processes. And because we model the materials that we want to make, then we go make them. Sometimes we make materials, go back and model what we did. This is an updated picture. This is where we were up to in December 2023. We've still got construction underway there, and we'll have a third wing with more solar. And by the end of this calendar year, will be a solar-fueled, battery-integrated light industrial site with needs created on-site, stored on-site, and used on-site. We've got a battery coming to land beside the main building there from a company called BASF, which is a chemical processing major from Germany. And the BASF battery, which is a 1.25 megawatt, 250 kilowatt hour battery, that means 5 hours at 250 kilowatt hours of delivery, it uses high purity alumina. Here's the hydromet floor, and where we're doing batch scale production for the purpose of delivering samples to market and provide engineering support to our licensees. And here's product. This is a couple of, on the right there, a couple of 10 kilo samples of HPA packaged to go to market testing in the USA with one of our licensees, Queensland Pacific Metals. So Lava Blue's doing it the way we think it should be done for battery materials, and that is de-risk the finance by de-risking the technology, scale conservatively, and prove the materials of construction and the handling systems. These are our three licensees at the moment: Queensland Pacific Metals, you just saw Stephen Grocott with samples going to the USA, Veco Group, which is a North Queensland vanadium processor, and Critical Minerals Group Limited, who are listed. Queensland Pacific Metals are listed as well. CMG and Veco are both working in North Queensland processing vanadium. The sweet spot for us there is we add a co-product to their developments using the waste post their vanadium processing, extracting the aluminium and producing 4,000 tonnes per annum is the plan at each site of high purity alumina. So this is meaningful in the scale of their projects, and it's using material that would otherwise end up back in a tailings dam. That makes it an extremely low-cost point of entry for these producers. Recovering elements that would otherwise have been lost, using the capital, leveraging off the capital of their primary focus, which in this case, in the case of Veco and CMG, is vanadium, and getting a very valuable co-product. This is the sort of business model that allows Lava Blue to perform the role of a materials science company and license the technology. We don't have to be primary producers ourselves to earn a buck. And we are not pre-cash flow. These companies are paying for the privilege of using the science. So in summary, we have started producing high purity alumina. We're de-risking downstream investments in hundreds of millions of dollars a plant by de-risking the technology first. We're hastening slowly to get our licensees into the market, giving them samples to test, providing engineering support. We leverage the money that we do raise highly with grants, with rebates, because what we do is R&D. We get 43 cents on the dollar back from the government. Thank you very much. And we have a very productive long-term collaboration with the leading university, Queensland University of Technology. This also gives us an enormous amount of leverage. The science that we use, the analytical capacity that we have, and the ability to scale and prove this technology because of that collaboration is unmatched. We couldn't bring all of that capacity in-house. It would be completely unaffordable. So in this collaborative development, we are commercializing science rapidly. Research, development, demonstration, and rapid commercialization. This makes us a slightly unusual company, but so far we've been succeeding quite well in this business plan. We're currently raising $1.5 million, of which we actually have 950,000 promised. So we've got a shortfall of about $550,000 at the moment. That will see us through runway to the end of calendar 2025, delivering on this demonstration program at Redlands. It's a tightly held, unlisted public company, though we do have plans to list. The new funds will drive this cohort of HPA licensees into the market, and we have a number of opportunities to bring new licensees on behind our 3 signed licensees. So as of April 1st, we had $1.5 million in the bank. We've got a further $1.2 million due to us over the next 12 months from a $5.2 million total grant we received from the federal government, specifically to work on developing co-products for the vanadium producers in North Queensland. And we have cash flow, both from our existing licensees, and we provide scientific services. We provide services for a fee because of our capacity and our collaboration with QUT to solve people's processing problems. We do have plans for an IPO, subject to, of course, market conditions and corporate development. The hope is that by the end of 2025, the intention is by the end of 2025, we'll have a timeline to listing for the core material science business. This is what we do. There's 2 of our prime leading scientists at QUT, Professor Sarah Cooperthwaite and Dr. Rachel Pepper. Research, development, demonstration, and rapid commercialization. That is what we do, and love to have people contact me to ask about joining with us in this program. That is my entire presentation. I hope that was enough of a short, sharp overview to provide you to get some interest from the viewers now.
Thanks for your presentation, Michael. A couple of questions.
Yes, thanks, Jamie.
What are Lava Blue's plans for its mineral properties and exploration portfolio?
Yeah, we've decided to focus on the material science core of the company, and we do have an extensive exploration portfolio in North Queensland where we operated for several years exploring for critical minerals. So we're spinning out the mineral properties into a series of subsidiaries. In 2022, we demerged a company called Boomer Minerals with about 1,200 square kilometres of exploration properties, and it's finding its own way as a pure minerals explorer focused on vanadium and rare earths. We have 2 more what we call Lava Blue babies in the pipeline, and shareholders in Lava Blue, of course, get a share of those entities as they are spun out. We'll simplify the corporate structure, spin out the exploration projects to the benefit of the shareholders and to find their own way, and we'll focus on the materials science.
What are Lava Blue's plans beyond high purity alumina?
Yeah, good question. So the work we've been doing in perfecting a method for extracting aluminium from numerous sources, and we've made high purity alumina from a number of different source materials, and purifying it to one of our recent efforts was 99.999% purity. That's less than 10 parts per million of total impurities. That has given us a wide range of skills and deep experience in using chloride chemistry. And the chloride chemistry allows us to produce other metal salts. So any metal that likes a chloride. So sodium chloride is your common table salt. And there are chloride routes for a number of other critical minerals. So while we're commercializing the work we've done in high purity alumina, we're starting to broaden the palette and look at other sources of elements that are happy, to bond with a chloride, because once we've got a metal salt, a metal chloride, there's a number of options to purify that to battery grade materials.
Thanks, Michael. As always, great to see you.
Thank you, Jamie. Happy to be involved.